Hello everyone. On this video we will be going over tests for symmetry. Okay, so first thing we're going to do is kind of explain what symmetry is on a graph. Okay, so first, a graph is symmetric with respect to the y-axis and underline that, symmetric with respect to the y-axis when every point x comma y on the graph corresponds to be with and a negative x comma y. All right, so let's look at that visually. Okay, so for example, let's draw our xy axis. Okay, so this is our x and this is our y. Now let's say we wanted to graph y equals x squared, which we're going to rewrite as a function, f of x equals x squared. Okay, so just to kind of get used to seeing it written this way. Okay, so we see there that y equals x squared kind of just looks like that. Okay, so let's say here that this, just for the sake of argument, is 0.11. Okay, it would show x equals 1 and y equals 1. Okay, that's your x comma y, your 1 comma 1. That's saying for this to be a graph that's symmetric with the y-axis, there has to exist, since we have a 1 comma 1, there has to be a negative 1 comma 1 on the graph. So this side is just negative 1 comma 1. Okay, so that's your negative 1 side there. Okay, so what if we go a little further up the graph? So what if this is 2 comma 4? So according to this definition of a graph that's symmetric to the y-axis, we have 2 comma 4, so there should be a negative 2 comma 4 on the graph. So that means you have a negative 2 comma 4. Okay, and that will go all the way up to 3 comma 9, negative 3 comma 9. So let's say if this is 3, the point 3 comma 9, on the other side, it would be a negative 3 comma 9. Okay, so really what they're saying is whether it's a positive x value or a negative x value, they will both share the same y value. Okay, so that's if you wanted to look at the definition. Visually, with respect to the y-axis, it's almost like you're holding up a mirror to one side. So if you held up a mirror on this side, it kind of looks like a mirror image on both sides. That's how you know just by looking at it if it's symmetric to the y-axis. Okay. All right, so if you're still writing, please feel free to press pause. I'm going to go ahead and go to the next part. And that's a graph that's symmetric with respect to the x-axis. Okay, so a graph is symmetric with respect to the x-axis. Okay, symmetric with respect to the x-axis. Okay, so that's when it's a little bit different, but that's when you have every point that's an x comma y on the graph will correspond with in this case, it's x comma negative y. Okay, so let's kind of help you visualize that a little bit. We'll do another example. Okay, so we're going to draw our xy axis. Let's bring that up a little bit. Okay, so we have our x and we have our y. Okay, so this time we're going to graph x equals y squared. And x equals y squared kind of looks like y equals x squared. The only difference is it's a parabola that opens up sideways. Okay, so just like before, where you had the same y value when you changed x's, here you have the same x value even though the y's are opposites. Okay, so here let's say you have x equals 1. That means you would have y can equal 1 or y can equal negative 1. Okay, because this is the point 1 comma 1 and this is the point 1 comma negative 1. Okay, so what if we had x equals, let's go down the line a little bit, let's say x equals 4. And make this a little bit longer. Okay, so if you have x equals 4, if you look at this equation, if you have x equals 4, that means y can equal either positive 2, because remember 2 squared is just 4, or it can equal negative 2. Negative 2 squared is just 4. So that gives you the point 4, 2, and 4, negative 2. When x is equal to 4, y can equal negative 2, or y can equal 2. Okay, so that's how you would look. It's kind of explain the definition of a graph that's symmetric to the x-axis. Visually, is just like the y-axis graph. If you kind of block off one side, it looks like a mirror image of each other. So if you have a mirror up right here, it'll look like it's just reflecting on both sides. It's almost like if you just flip it over, it's the exact same graph. Okay. Now, one thing you want to notice, especially when we start talking about the tests for symmetry next, is that if you notice, it fails the vertical line test. So even though this graph is symmetric with respect to the x-axis, this graph does not represent a function by definition. Because remember, for a function, for a graph to be identified as a function, each x value can only have one y value. And here, x equals 4 has a y value of 2 and negative 2. So it is not a function. We're going to find out next how to find odd and even functions using this idea. Okay, so if you're still writing, feel free to press pause. But we're going to go ahead and go to the steps to test to see if a function is odd or even. Okay, so we have the actual test for symmetry. Or in other words, you have your odd and your even functions. Okay, so starting off, we'll look at the test for an even function. Let me give me a little extra pencil lead here. All right. Test for an even function. Okay, now a test for an even function, you have two steps. Your first step is you're going to replace every x with negative x. Okay, that's your first step. A little extra pencil lead here. Got to replace it. There you go. Okay. Now your second step, you're going to look to see what happens when you replace that negative x. If the function f of x is the same as f of negative x, remember you're replacing the x with negative x, then the function is symmetric across the y-axis. Or in other words, it's an even function. Okay, so remember, when it's symmetric across the y-axis, it's an even function. Okay, so this allows us to find out if it's odd or even without being able to actually see the graph. All right, so let's say, for example, we wanted to verify whether the functions are even or not. Okay. So let's look at problem A. We have f of x equals x squared plus 1. And problem B, we have f of x equals x minus 2, and that entire thing squared. Okay, so let's start with A. Okay, so we see here that for problem A, let me move that up a little, f of x is equal to x squared plus 1. So to test to see if it's even, we're going to replace that x with negative x. That means that f of negative x equals negative x squared. Remember, you don't want to just put a negative in front of there. You're actually squaring the entire negative x plus 1. Okay, once you do that, we can see here that negative x times negative x, let me kind of write that in the corner. Negative x times negative x is just x squared, because negative times negative is positive and x times x is just x squared. So you have positive x squared. So that is equal to, this just becomes x squared plus 1. Okay, and we see here that x squared plus 1 is equal to f of x. So that lets us know that f of negative x is equal to f of x. So we see here that this is an even function. Okay, so A is an even function. Okay, now let's look at B. So we have f of x equals x minus 2 squared. Okay, so first thing we want to do is find out what we get when we replace x with negative x. Okay, so f of negative x is going to equal negative x minus 2 squared. And that really just simplifies to become negative x minus 2 squared, which really is not the same as our f of x. So this does not equal f of x. So here we see that f of negative x does not equal f of x. So we know that this is not an even function. Okay, we will know what category this would fall in a little bit. But right now, we're just verifying whether it's even or not. All right. Okay, so if you're still writing, feel free to press pause. But we're going to go ahead and go to the odd function. Okay, so just before we do that, remember, when it's symmetric to the y-axis, it's even. Okay, now the odd function is a little different than you might be expecting. A graph is symmetric with respect to the origin when you have a point x comma y is on the graph and corresponds to negative x comma negative y. Okay. Now this is the definition of an odd function. Because remember, when it's symmetric to the y-axis, that's an even function. If it's symmetric to the x-axis, it fails the vertical line test. So it's not a function by definition. But an odd function is not symmetric to the x-axis. It's symmetric with respect to the origin. That's the thing you have to remember. That's why it's a little bit different than an even function. Okay, now with respect to the origin, let me give you an idea of how that would look. Okay, so what if we have our xy axis? Let's move that up a little bit. All right, so if we have our x, and we have our y. Okay, so let's say if we have a graph that looks like this. Okay, so looking at this particular graph, let's say if we have a point, actually make this a little bit taller. And this a little bit lower. Okay, so let's say here if we have the point that we'll call 1, 2. X is 1, y is 2. And let's say here we have another point on the graph where x is 3 and y is 5. That means for this to be symmetric with respect to the origin, our 1, 2, there would have to be a -1, -2 on the graph. Okay, so I'll stay there. So -1, -2. And if we have a point 3, 5, so 3, 5, there would have to be a -3, -5 on the graph. So let's say this is our -3, -5. Okay. Now, if you were just looking at the graph, you would have to flip this portion. Let's say if you're looking at just this part of the graph, you're kind of blocking this out. Looking at this part, if you flip it over the y-axis, it would kind of look like that. So you're flipping it over the y-axis. Then if you flip it again, this over the x-axis, it should line up perfectly with this graph. So if you have a graph that you can flip over the y-axis and then again over the x-axis, that's how your graph should look. That's how you know it's symmetric with respect to the origin. Okay, so now let's look at the steps to test for an odd function. All right, kind of block that off here. Okay, so now we'll look at the test for an odd function. Okay, so again, you only have 2 steps. 1, replace every x with -x, and that's the key. You have to do y with a -y. Okay, so with this one, you have to do both. Where just for an even test, you replace x with -x. But for an odd test, you have to replace x with -x and y with -y. Okay, but just remember, you just replace f of x with y. Okay, so if you have f of x equals something, you just make it y equals that function. Okay, then we go to our second step, which is the same as the even test. You get the same function, or let me say y equals f of x. After replacing x and y with -x and -y, then the function is symmetric about the origin. Or in other words, it's an odd function. Okay, so it's just a little bit different than a test for an even function. Okay, if you notice, if we got rid of that step there and just replace x with -x, that's a test for an odd function. If we did both, it's a test for it's a test for even function. If we do both, it's a test for an odd function. Okay, so if you see it, if you kind of remember one, you can remember both. So hopefully that helps you kind of remember it a little bit. All right, so if you are still writing, please feel free to press pause. But we're going to go ahead and go to our examples. Okay. All right, so let's say for our first example, let's say is the function f of x equals x to the third minus x, odd, even, or neither. Okay, it is possible for a function to be neither odd nor even. Okay, so if it fails both tests, then it's neither. Okay, so first, we're going to test for an odd function. It doesn't matter which test you do first. Yeah, we'll do even since it's a little easier. Okay, so if we test for an even function, we know that f of x is equal to x to the third minus x. So that means we want our f of negative x to be the same thing, which is negative x to the third minus negative x. Okay, so negative x to the third power, I'm going to go ahead and write that out. We have negative x times negative x times negative x. That's going to equal negative x to the third. Since negative times negative is positive, that positive times negative is negative. So that's actually equal to negative x to the third minus negative, so that's plus x. Okay, so we can see here that that does not equal our f of x. So f of negative x does not equal f of x. Okay, so we can see here that it's not an even function. Okay, so we can actually eliminate the idea of it being even. Okay, that doesn't mean it's automatically odd. It could be neither one. Okay, so let's do our next test, which is a test for an odd function. Okay, so instead of f of x equals x to the third minus x, we're going to make it y equals x to the third minus x. Okay, now remember, you're going to replace x with negative x and y with negative y. Okay, so that y will become negative y. You have negative y equals, I'm going to replace that with negative x. You have negative x to the third. The parentheses help a lot when you have a power that's different from 1. Okay, so minus, and again, I'm going to put negative x there because we have a minus sign there. Parentheses help to avoid little mistakes. So it's a good habit to get into. All right, so let's go ahead and simplify this. We have negative y equals, we see here that negative x to the third, we did that up here, that's negative x to the third minus negative x. We can make that plus, plus x. There we go. All right, so here we have minus y. We're not solving for minus y. We need to know what positive y is. We have it up here. Okay, so if we divide or multiply each one of these by -1, so -1, -1, -1, doesn't matter if you multiply or divide, same thing. All right, negative divided by negative is positive, so you have y over 1, or just y, equals negative divided by negative is positive, so you have positive x to the third. Positive divided by negative is negative, so that's minus x. So after you replace y with negative y and x with negative x, you end up right back where you started. Okay. So since you end up right back where you started, you know this is an odd function. So this function is symmetric about the origin. In other words, it's an odd function. All right, so it just takes a little bit of practice. All right. So let's look at an example. We saw an example of an even. We see an example of an odd function. Let's look at an example when it's neither. All right. Okay, so let's say, for example, let's say if we want to see if x equals y to the fourth plus 2y squared, odd, even, or neither. Let's try the even test first. Okay, as you know, you can replace x with negative x. Okay, so if we replace x with negative x, that gives us negative x equals y to the fourth plus 2y squared. So if we replace or divide each one of those by -1, negative divided by negative is positive, so you have x equals negative y to the fourth. We're not going to use the parentheses because that's dividing that whole thing by -1, not the y, minus 2y squared. Okay, so we see here that this is not even with that. Okay, now if these two were the same, or you ended up with x equal and both those were the same, you see there, or even if you decide to rewrite it by factoring out a -1, you have negative y to the fourth plus 2y squared. It's still not even with where you started, or not the same as where you started. So you see here that it's not even. Okay, so we know it's not an even function. All right, so let's try the odd test. Okay, so the odd test, remember, replace x with negative x and y, move that down a little bit, y with negative y. All right, so if you have an odd test, we're going to replace that x with negative x. So you have negative x equal, that y is replaced with negative y. So you have negative y to the fourth plus 2 times negative y squared. So kind of box that out a little bit so it's not confusing anything. Okay, so we replace x with negative x and y with negative y. Okay, so that gives us, if we decide to simplify it, negative x equals, and we kind of put on the side, negative y to the fourth power, and that's negative y times negative y times negative y times negative y. Negative times negative is positive, that positive times negative is negative, negative times negative is positive. So you end up with just y to the fourth power. So we have y to the fourth power. Same thing here, if you have negative y times negative y, that's just positive y squared. So it's plus 2y squared. And just like here, if we divide everything by negative 1, we end up with x equals negative y to the fourth minus 2y squared, where no matter if we put it either way, it still wouldn't be the same as the x value we started with. Okay, so we know this is not an odd function either. Okay, so it's not even and it's not odd. That lets us know that x equals y to the fourth plus 2y squared is neither odd nor even. Oops, sorry about that. Okay, so it's neither an odd function nor an even function. All right. Okay, so if you're still writing, feel free to press pause. We're going to go ahead to the next example. Okay, so let's say, for example, you want to determine if the function is odd, even, or neither. And what if we have g of x equals x to the fourth minus 2x squared minus 5. Okay, so again, you can have g of x or f of x, doesn't mean anything either way. Either way, the tests are still the same. All right, so what I want you to do is I want you to press pause and try to do this one on your own. All right, so assuming you press pause and work this one out on your own, we're going to try and verify your answer. Okay, so first we test for an odd function. Okay, so remember, for an odd function, we replace x with negative x and y with negative y. Now, of course, that just means that y is going to equal our g of x. All right, so instead of g of x equals x to the fourth minus 2x squared minus 5, we're just going to make that y equals x to the fourth minus 2x squared minus 5. But if we go ahead and replace y with negative y, that's negative y equals, and x, we're going to replace that with negative x. You have negative x to the fourth power minus 2 times negative x squared minus 5. All right. Okay, so we know that negative x to the fourth power, negative x times negative x times negative x times negative x is just x to the fourth power. We have negative y equals x to the fourth power. Negative x squared is just negative x times negative x, so that's just positive x squared. We have minus 2 times x squared. You don't want to go minus negative is positive because you have that square. You have to get rid of that square first before you can do that. Okay, so negative x times negative x is positive x squared. That's why those two don't become plus. Minus 5. Okay, now this would be okay, but we have that negative in front. So divide everything by negative 1. Okay, so negative divided by negative is positive. So we have y equals, positive divided by negative is negative, negative x to the fourth plus 2x squared, negative and negative is positive, plus 5. Okay, so we can see here that this does not equal that. Okay, so these two are not the same. So we can see there that it is not an odd function, since it failed the test for odd functions. So now we can do the even function. Okay, so test for even. Remember, that one you just replace x with negative x. Okay, so that means our g of x is x to the fourth. We're looking for g of negative x. Okay, so that's going to equal negative x to the fourth minus 2 times negative x squared minus 5. Remember, those parentheses are really, really, really important. If you don't put in those parentheses, it's really easy to make a little minor error and throw your whole reasoning off. All right, so you see here, negative x to the fourth power, that's just x to the fourth. So g of negative x minus 2. Remember that negative x squared is just x squared. So that's minus 2x squared minus 5. So you can see here, x to the fourth minus 2x squared minus 5 is equal to our g of x. So that lets us know that g of negative x is equal to g of x, okay, which means it's an even function. So g of x is an even function. Oh, bring that up some. All right, so hopefully that made some sense. Okay, so now we're going to go into some graphs. Okay, so you might not be able to write these down, but we're going to have you follow along. Bring that down a little. I printed these up ahead of time. Okay, So we want to know if the graph shown is odd, even, odd, or neither. Okay, so if you look at it, remember, if you start just in this corner, if you flip it over, it's not an even function because it's not symmetric across the y-axis. But if you get this part of the graph, you flip it over here, and then you get it and you flip it again over the x-axis, you end up right where this graph is. So if you flip this portion across the y-axis, then again across the x-axis, that's how you know this is an odd function. So this is actually an odd graph. Okay, so sometimes they'll give you the equation without the graph. Sometimes they'll give you a graph without an equation. Okay, so this is just one of those cases where as long as you know the concept, you can still figure out whether it's odd, even, or neither. Okay, plus you can look at some points. Here you have the point 3, 4. Okay, so you have 3, 4. Since it's an odd function, you should have a -3, -4. So if you go -3, -4, boom, right there. -3, -4. And you can do that for each and every point on the graph. All right. Okay, so let's do another example. Okay, so is this, straighten that up, odd, even, or neither? Okay, so if you look at just this portion here, let me get a sheet of paper to block off. You always want to start with the first quadrant over here. Okay, so you can see here that it's not just a mirror image over the y-axis, so it's not an even function. Plus, if you get this and flip it over and then flip it back, it's not going through the origin. It has to go through the origin in order to be symmetric about the origin. Okay, so it's not an odd function either. So this one actually falls under the neither category. Okay, so let's do another quick graph example. Okay, so this one odd, even, or neither. If you look at it, it looks like a mirror image on both sides of the y-axis. So this one would actually fall under an even function because it's symmetric about the y-axis, or symmetric across the y-axis, however way you wanted to actually word it. All right, so let's look at another one. Okay, so what about this one? Is this one odd, even, or neither? Okay, so if you guess neither, you guessed correctly. It's not symmetric across the y-axis, and if you flip this over and this over, you won't get the graph continuing in the third quadrant, so this one falls under neither. All right, so let's do another one. This one even, odd, or neither? If you look at this side of the graph, it's identical across the y-axis on to this side of the graph. So these two look like mirror images of each other. So this one actually falls under even because it's symmetric across the y-axis. Okay, hopefully this is starting to make a little bit of sense. All right, so we got one more, and I want you to try this one. I'll give you a few seconds. Is this one even, odd, or neither? Okay, if you need more time, feel free to press pause. All right, I'm assuming you've pressed pause and you studied this graph. So let's take a look. If you look at this portion here, this doesn't go like that. So you know it's not even. It's not a mirror image on both sides. But if you look just at this portion here, you notice if you mirror it here across the y-axis, and then flip it across the x-axis, it picks up on the graph here. So this entire graph, if you flip it over and then flip it over again, it gets right on that graph there. So that's how you know that this is an odd graph, because it's symmetric about the origin, or symmetric across the origin, however way you want to say it. All right, and I think that, yep, that's the last one. Okay, so hopefully this made sense, and I will see you on the next video.